Welcome back to Lesson 3, Part 2. And when we left off, we had just completed the tape diagrams or the arrays of 3 parentheses x plus y. Please notice that all of these are equivalent. 3x plus y, if we go back to our definition of the distributive property, we have 3 parentheses x plus y, which this is the product, is equal to 3x plus 3y, which is finding the sum. So when you think about which one is the best illustration of the distributive property, you're probably looking at this right here. Now let's move on to the next page. Example 3, find an equivalent expression by modeling and apply the distributive property. So I'd like for you to pause the video and come back as soon as you're done for us to check and take a look. Now that we're back, hopefully you have drawn this tape diagram, this array. And if we take a look, we want 5 groups of 8x, which would give us 40x. And we want 5 groups of 3, which would give us 15. So we now have, let's take a look at where we started and what that equals. And let's see the connection. So 5 times 8x is equal to 40x. And 5 times positive 3 is plus a 15. So notice the relationship with this one and this one. So if we move down, and of course let's go back, to this being the product and this providing the sum. This is the same as 5 times 8x plus 5 times 3. Now let's move down to exercise 2, and there's 2 things we're going to do. We're going to actually start off first and use the distributive property to expand this expression. So I'd like you to pause your video and complete the array for 2 times x plus 1. We're back, and do you have an array that looks like x and 1 with 2 groups? And when you do the multiplication of 2 times x, you get a product of 2x, and 2 times 1, you get a product of 2. So as we look here, I'm showing you the distributive property. 2 times x is 2x, and 2 times, don't forget this plus 1, is 2. Notice the relationships here. Now this next part says we're going to actually substitute 5 in for x and prove whether the distributive property works. So I'm going to rewrite this equation. The product and the sum. And now I'm going to substitute 5 in for x. Two times 6 is equal to 10 plus 2. 12 is equal to 12. So this proves that the distributive property is accurate and that the 2 sides, the 2 expressions are equivalent. Let's move down to the next example. Pause your video and draw your array. Okay, now you're back. Taking a look at 10 times 2c using that distributive property gives us 20C. 10 times 5 is 50. And that's just showing 10 times 2C and 10 times plus 5 or positive 5. So now we're going to test it again. And we're going to come down here to C, that C is equal to 1. And we're going to plug C in or substitute 1 in for C and check for equivalency. So 2 times 1 plus 5, 10 times 2 plus 5, 10 times 7 with a total of 70. Let's try the other side. 20 times 1 plus 50. 20 plus 50, which equals 70. So yes, we now have proven the equivalency again. So I would like for you to pause the video, and I want you to complete C and D, doing the exact same things we were just doing, drawing the array. Don't draw an array this time, but I want to see if you are able to use that distributive property. You can use your previous examples to assist you, and come back when you're done. Okay, this time we're taking a look, but we didn't draw the arrays, so we want to make sure that we followed all the procedures to utilize that distributive property. 3 times 4f, remember that coefficient is adjoined to that variable of f. Keep that sign, minus 3 times 1. Did you get that? 12f minus 3. So now that we have this, we want to test the equivalency. So we've rewritten and we have substituted. 3 times 4 times 2 minus 1 is 3 times 8 minus 1, which is 3 times 7, which equals 21. On the other side, we have 12 times 2 minus 3, 24 minus 3, and again 21, proving equivalency. So were you able to utilize that distributive property on the other side? Negative 27r minus 99. Now this gets tricky because you have to remember that this negative 3 is attached to that r. It's the coefficient with the variable r. So 9 times negative 3r is negative 27r. And don't forget this minus sign. Continue it here. Minus a positive 9 times 11 is 99. So now we've set it up to also again test for equivalency. So look over your work and see if you came up with the same answers and the same steps. Feel free to pause the video if you need to. And yes, equivalency was found. Okay, rewrite the expression 6x plus 15. So, divided by 3. Well, this looks a little bit different because that distributive property. One thing is remember that we can multiply using the multiplicative inverse. So my first step is going to be to use that multiplicative inverse and change this division to multiplication. And since 3 is the same as 3 over 1, the multiplicative inverse becomes 1/3. So we're actually multiplying times 1/3. If you feel the need to put the 1/3 in front of the parentheses, you can, but it's also good in the back. I'm going to move it up front so that we can just continue the same look that you already had. So now we're going to distribute to 6x. So 1/3 times 6x plus 1/3 times 15. So 1 times 6x, we've got this 6x over 3 plus, remember if you made this a fraction, you would end up with 15/3. So what is 6 divided by 3? You should have 2x plus 15 divided by 3 is 5. And this is the standard form because we have combined all the like terms. Let's move down to A. We'll do one more together and then I'm going to let you do it. So dividing by 2 is we're going to use the multiplicative inverse, and we're going to get times 1/2. So we can use it in the back without any problems. So we get 2b times 1/2 plus 12 times 1/2. So we're just distributing in this way. 2b over 2, because 2b times 1, plus 12 times 1, divide, and you get b plus 6. Okay, pause your video and come back after you have completed B and C. Okay, at this point you may want to pause again if necessary. I want you to take a quick look and see if you were able to come up with the same solutions. Or the same expressions. If not, you need to pause and go through each step and make note of any changes or adjustments so that you can identify where your mistake occurred. Okay, our next step that we're going to take a look at is again looking at an array. And we're going to expand this expression, and I've done one for us. Expand the expression 4 times x plus y plus z using an array, and then come up with the expanded form here from the distributive property. So as you've noticed, I have completed the array, which gives me 4x plus 4y plus 4z, 4 groups of the sum. Pause your video and complete the next one. Welcome back. And were you able to draw the array and then illustrate how you are able to get 3x plus 6y plus 15z? Fantastic. You're really getting a handle on the distributive property. So now finally we're going to take a look at this last section here, and I want you to notice that we're trying to figure out how many tiles it would take to make a border of this fountain. Take a note here that these corner pieces are not part of the sides, so those are an extra piece. So if we had 4 per side, then we would have 4 times, there's 4 sides times what the side is. So 4 times 4. And then we have additionally 4 corners, which totals 20. Now you may be wondering what does this have to do with the distributive property? Well, you actually have 1 corner attached to each side. So your distributive property would be 4 times s plus 1. And for your last and final, following that same 4 times the sides plus 1 extra tile per side, 4 times 2 plus 1, and you would come up with a total of 12. Thank you.